Welcome back to Bafuni Academy. We are continuing with our topic on growth and development. Now we are going to talk about, plateau, okay, plateau stage. The normal sigmoidal curve looks like that, okay? And at this stage, when the curve is relatively flat, this is what we call stationary phase, okay? Stationary phase or plateau. Phase. Now, in some living organisms, it's not always the case that this curve will always be flat, okay? In some plants, let's say monocotyledons, we'll find that this graph tends to increase, okay? And in other animals, when you try to, measure some parameters like weight, you'll find that at this point, the graph will tend to fall. Okay, so we are going to look into those scenarios, then bring mathematics into it, and try to understand it better. Now, this is something that you're not going to find in books, in textbooks, and that's why at Bafunde we are not leaving any stone unturned, and we are going to do that. So let's look at the first scenario where the graph, okay, continues slightly until the animal dies, or until the organism dies. It may be an animal, it may be a plant, but some parameters will usually continue. So let's start. Okay, so I'm using a ruler. Okay, you can draw the x-axis. Okay, so we have our x-axis, we have our y-axis. Remember, when you draw graphs without using naming those, you will find, you will miss marks. So our 0.0 starts there. Okay. So here I'll mention x-axis. And now here we'll have, also some points. Okay. And then our sigmoidal curve will go like that. So I'm going to, be interested in this particular point. And as I mentioned, now it's not going to be, this straight. What's going to happen is that we are going to have the curve, continuing. Okay, it will continue like that. Okay, now if you try to calculate the gradient of this particular curve at that particular point, you should be able to see if the gradient is positive or negative or zero. So let's say at this point we have 80. So let's say this point is 80, this point is, so this will be 70, this point is 65. Okay, then at this point, so this, because this is time, okay, in, let's say days, and here is a parameter, let's say a parameter like length in meters. Okay, so when you want to get the gradient, okay, of this curve, the gradient of this curve, okay, we can just draw a triangle, okay, on it, and we just find, change in y over change in x. So we know that gradient is change in y all over change in x. Another way we can say it's dy all over dx. That's how we can express change. This small triangle, okay, delta, means change, and it can also be written as this. Now, so this is going to be our length naught, okay, and this is going to be our length 1, okay. This is going to be our time 1, and where the time starts is time 0. So change in y over change in x is going to be, we have, length 1 at this point is 100, we subtract length naught, which is 80. So for us to know this change, okay, for us to know the change in this height, okay, we subtract 80 from 100. So that is going to be 100 minus 80. Now for us to know change in x, down here, we need to know this, this distance. And this distance is equal to 65. We subtract it from 80. So it's going to be 80 minus 65. Okay, so our change in y over change in x is equals to 20 divided by, okay, this is 15. If you divide both by 5, you are going to get 4 over 3, and that is 1, okay, and a third, which you can also write as 1.333, and that is recurring. Now, something that I would also want to show you, you see that this gradient is positive, meaning the growth continues but slowly. So there are some organisms, as I mentioned, some plants, such as sugarcane, the height will continue to increase, let's say in terms of the length of the leaves, until the plant will die or until we cut it and eat it, okay, or chew it. Other plants include monocots, like maize. The height will continue until the plant will dry up. Let's look at the second scenario. And in this second scenario, we are going to continue to draw our graph. Let's now be a little bit quicker. Okay, we are going to continue drawing our graph. Perfect. So we have our x-axis, we have our y-axis. So we know here we have a parameter, we have time. We have time in form of days, and here we have our parameter, and we are going to use the same. So here we have our parameter, and in this time I'm going to use height h. Okay, I'm going to use height as a parameter, and we are going to measure it in meters. Okay, in meters, because here I want to write figures. Now here we are going to have those parameters. We are going to still use at this point we are going to use this to be 80, and this to be 60, this to be 40. Okay, just to mention, probably here will be here to be 60. Okay, I'll draw the graph. Start somewhere. It's now. I want you to notice here is going to be flat. At that point, the graph becomes flat. Okay, so this is the second type of plateau phase that we have. If you have been told to get the gradient, you take any 2 points. For example, I'll take this point. And this point, and get the gradient of this line. I'll try to get the gradient of this line. So we know that at this point we have 80. Okay, here probably we have 60, 40, 20, we have 0. Okay, so at this point we know that gradient is equals to change in y all over change in x. So that is the same as dy all over dx. Okay, so for us to get dy is here. Okay, we can extrapolate and see that the value is at 80. And here's where we have our h0 and h1. H naught and H1 is the same, meaning the height of this particular organism has not increased at all. Okay, so for us to get dy, it will be H1 minus H naught over here we have our time 1, we have our time naught, so it will be T1 minus T naught. That will give us 80, that will give us, yes, 80 minus 80 divided by this one, this change is equals to 80 minus 60, and so we have 0 over 20. Don't cancel this 0 and 0 and tell us the answer is 2. No, 0 divided by any number is equals to 0. Okay, so when the gradient is 0, it means that the stationary phase is flat. Now, some of this graph will be, exhibited in organisms like human beings. Okay, human beings. When you measure parameter like height, our height is being determined by bones. Height is being determined by bones. Now, bones don't shrink in length. Okay, so if you let's say you are at 50 years or at 30 and you have grown to 4 meters maximally, even if you grow, you become 75 years, you may bend, but if we straighten you, your height will still be 4 meters. Okay, so let's continue to the third state and see, what can happen in the different plateau curve. So we'll draw our curve again, draw our graph again, growth curve. And you see how I'm trying now to make my work very clean. Okay, you will bear with the sound of the ruler. Bear with the sound of the ruler. Now, in this case, okay, we're still going to use a point 80 and we are going to use a point 60. Okay, so you can have 40, you can have 20, you can have 0. And then it's still the same, 20, you can have 40, you can have 60, you can have 80. Now in this case, the graph goes up as usual. After decelerating phase, it starts to fall. Okay, and probably it will fall to somewhere, let's say there. Okay, now in this case you are seeing the normal plateau curve we know should actually be flat like this. Okay, but now in this case we are having the one that falls, okay, like this. So in this case, for us to get the gradient, okay, we know that for us to get the gradient, if we want to see what type of growth we get the gradient, and we know that gradient is equals to change in y all over change in x, which is equals to dy dx. It's the same. So we'll take this point to be 80 and this point to be 60, as we have done in others. Now this is time 1, this is t naught, because this is time in days. Okay, this is our parameter. Now this parameter is not height this time, it's, let's say, weight. Okay, this time let's say it's weight in kg. Okay, so for us to get dy, which is this, we'll extrapolate here and say we want to measure it from here. I'll still extrapolate it to fit to 80, and then we'll measure it to this point, and this point is 40. So we know that this is where it starts. So this is going to be our k naught, and this is our k1 because it's kilograms. Our dy is going to be k1 minus k naught divided by t1 minus t naught. Okay, so k1 is equals to 40, k naught is equals to 80, and our t1 is equals to 80 our T naught is equals to 60. So you're going to get negative 40 divided by 20, and you're going to find the answer is equals to negative 2. Okay, now when you find the gradient to be negative 2, okay, it means the parameter is decreasing as the living organism ages. Let's take, for example, a point in case, the weight of a human being. Okay, now as you grow, let's say from 10 years, the weight increases, and depending on how you eat, until it reaches a maximum peak. Now when you get old, you may lose that weight. Okay, you lose that weight. Now this curve does not apply to people who have lifestyle diseases like diabetes, because if they have diabetes, the weight will just increase. So exceptional cases is people who have diabetes. So those are the three different plateau curves. We have one where the plateau curve continues to grow, but gradually until the organism die. Okay, the second one is where it's actually flat, the gradient is 0. Okay, and then the third case is where the plateau, instead of being flat, it falls. Okay, and we find the gradient to be negative. Okay, so those are the three. This kind of lesson, you will not find it in any book, and I bet you have not been taught biology like this in class before. Now if you have followed, I am a very happy man. If you have any question about this or anything that you have learned in this topic, please don't hesitate to ask in our question forum. Now, go and try the quizzes that are attached to this particular lesson and try to see if you can answer those questions. Now, for all that, see you in the next lesson.